So we're just waiting a couple minutes to let some folks join here.
Yes, I have 12:59, so maybe give people a couple more minutes and then we can get started.
Okay, yeah, sounds like a plan. Just let me know when we're ready to go.
Okay. Okay, John, I think you're good.
Okay, thank you, Ree. Good afternoon, everyone. My name is John Lukowitz with Sandalwood Engineering and Ergonomics. And I want to thank you all for joining us this afternoon to talk a little bit about the Siemens Process Simulate tool and how we can use it to optimize our processes, optimize our workstations. So thank you for joining. A little bit on our agenda here. We'll go through a quick round of introductions. We'll have an overview of the Siemens Process Simulate tool. And then we're going to dive into some specific capabilities, tools, and methods. So Process Simulate is a very, very broad tool, has a lot of uses, a lot of capability, but we wanted to focus in the areas where our clients find the most value. So the topics of discussion today will be process development, tooling studies, layout development, digital human modeling and ergonomics, and virtual reality. And then, of course, we'll save some time towards the end for a question and answer session. If you do have any questions as we go through this, please feel free to post them in the chat, and we'll be monitoring the chat so we can share our views or expertise on any questions that you may have. To begin, just a little bit about us. So again, my name is John Lukowitz. I'm the technical lead for digital engineering with Sandalwood Engineering and Ergonomics. We work with a variety of digital engineering tools, advanced manufacturing tools, including several softwares in the Siemens tool set. So namely, those would be Process Simulate, Viz Mockup, Teamcenter, which is their PLM solution. And then we also work in Jack and or Process Simulate Human. I'll pass it over to my colleague, Mitch Carswell, to just say a few words about himself.
Awesome. Thanks, John. So as John mentioned, my name is Mitch Carswell. I am a certified professional ergonomist and a team lead for our injury prevention group at Sandalwood. So I'm going to really be focusing in on the use of the digital human model and how we can leverage that to ensure human-centered design upfront in the when we're completing these assessments.
Thanks, Mitch. And then we're also, we're a technical partner with Siemens. So we're joined here today by Brian Shea, our Siemens representative. Brian, if you wouldn't mind just saying a few words about yourself.
Yeah, hey, thanks, John. My name is Brian Shea. I'm responsible for supporting the Siemens manufacturing planning solutions in the United States and Canada. And that includes this solution that we're looking at today that's called Process Simulate. So Siemens works closely with our partners at Sandalwood, and Sandalwood provides outstanding services to support people that are using the Siemens Process Simulate solution and some of the other solutions that John mentioned there. So we're going to explore some of these capabilities in this session today. I'm looking forward to the discussion. Feel free to put your questions in the chat or the Q&A area. We'll get to them, probably hold the questions to the end. I think this will be very informative for all of us.
Awesome. Thanks, Brian. And then just a little bit about Sandalwood. So we were founded in 1989. We've been around for a little bit. We were really born out of Ford's Advanced Manufacturing Technology Division. So we've done a lot of work in the automotive industry, but we also do a lot of work in other industries as well. We've completed thousands of projects in that time. We have operations all over North America, so offices in the US, Canada, and Mexico. And we have a little over 125 employees. I'm not going to go through each of these, but I do think it's important. These are Sandalwood's core values. You know, they're just integral to everything that we do, how we interact with our colleagues within Sandalwood, how we interact with our clients and serve them. So very important to us and inform everything that we do. And then just a little bit about Sandalwood's structure. So we are made up of 3 divisions or lines of business. I'm with the systems engineering group, which is primarily focused on things like manufacturing, project management, and then also utilizing a variety of advanced manufacturing tools, digital engineering tools, one of which we'll see today in Process Simulate. Mitch is with our injury prevention team, which is really focused on ergonomics and safety. And then we also have a systems integration team that's focused on controls engineering. So, you know, if any of those areas are an area of need for you, we may be able to help, and we'd love to talk to you about our capabilities and expertise. So now getting to why we're all here today, to discuss Siemens Process Simulate. So this blurb here is a little wordy, but I pulled it directly from the Siemens software, and I think it's good to just get us grounded on what the technology is and what the tool is that we're working in. So Process Simulate is a digital manufacturing solution for manufacturing process verification in a 3D environment. It's an enabler of speed to market by allowing manufacturing organizations to virtually validate manufacturing concepts upfront throughout the life cycle of new product introductions. By leveraging 3D data of products and resources that facilitates virtual validation, optimization, and commissioning of complex manufacturing processes. Ultimately, this results in a faster launch and a higher production quality. So that's a lot, but how are we using this, right? How do we add values for our clients with this tool? Well, ultimately, we're using it for the design, assessment, or validation of any kind of physical asset that would end up on the production floor. So those would be things like product, tooling, layouts, processes, ergonomics, our operators. And we're doing all of this in software rather than utilizing, you know, some kind of physical trial or physical mock-up. We'll talk a bit more about timing in a bit, but we can utilize this approach at any point in the life of a project. But we've really found that it adds the most value when we start as early as possible and then continue throughout the life of the project or program. We utilize a very highly iterative approach, right? Things are constantly changing as we're designing these manufacturing systems. So we're continuously updating our models as our inputs mature. And then ultimately, this leads to a significant cost savings due to far fewer issues at launch. We're often asked again, you know, when should this kind of approach or methodology be used? And the fact is we can use it at any point in the manufacturing design process. So if we start very early, we can often get the most value, but typically we carry these activities all the way through the manufacturing design process, through launch, and then we can even use these kinds of tools for post-launch activities, continuous improvement, those kinds of things. And then a little bit about the inputs for these simulation models, right? So we want to incorporate all of the relevant information that's relevant to the manufacturing process into one common simulation model. So again, those inputs are things like product, your process, models of your tooling and equipment, your material handling strategy, models of material handling items, the layout. And by considering all of these things in a common model, we can really look at interactions between the different elements of the system and use a system approach to design. And at the center of it all is our operators, our humans. How does this manufacturing system affect them? We want to include as much detail as is required to achieve whatever our desired result is from the study. And we can do this for, you know, any scope or scale. So we've done this for one workstation or one product or one tool. And even with some of the larger automotive OEMs we work with, we've done this for up to, you know, 500 stations for multiple engine assembly lines that are launching at multiple plants simultaneously. So you can really scale the scope of the project, of the simulation, to whatever your needs are. I'm going to turn off my video here just in the interest of bandwidth, so these videos hopefully come through nicely. And we'll get into the first area of discussion here, which is process development. So again, we can start very early on. One sec, my video's not playing here. There we go. We can begin very early on with very limited inputs, right? So essentially, if we just have some product in a preliminary process, we can start in looking at these things. And usually this means working very collaboratively with various engineering teams to develop the process as early as possible. And oftentimes these are groups that may not even, talk to each other. They're all working in their own sandbox, and we use the simulation model to bring everyone together. Early on, we're looking at things like assembly sequence and feasibility. How are we, putting this thing together, in what order, which steps happen when, at what point. Doing early time studies and work balancing to optimize the cycle time. And then some early ergonomic studies looking at the assembly height and orientation. What is the effect to the operators of assembling whatever we're looking at? Very critical, if we can identify any kind of major roadblocks or issues, we can usually get product changes implemented before they become, really costly. As we all know, issues and problems become exponentially more expensive as the project progresses. So if we can catch these things early, we can resolve them pretty easily. And then as our designs mature, our simulation model becomes more robust and more valuable. So on the right here, we can see an example of a much more mature simulation model. And again, our inputs are maturing, and we bring those into the simulation. So once again, things like product, process, layout, tooling and equipment, material handling. And at this point, we can really start to finalize our manufacturing process. So we can finalize our processes and our layouts. We can verify all of the tooling that's on the line, make sure that it's going to operate as expected with no issues. Also looking at things like time study finalization, right? Making sure that everything is in cycle time, the line is going to flow well, and also doing in-depth ergonomic studies, right? And Mitch will be giving us a pretty in-depth overview of some of the ergo studies that we do in Process Simulate a little later on. So just an example of a more mature simulation model as we progress through this process. More specifically, some of the certain kinds of studies that we do a lot of tooling studies, right? So this could be for any kind of equipment that's going to ultimately end up on the plant floor. So those would be things like robot grippers, presses, rundown tools, lift assist, the pallet that the assembly is traveling on. We can even take a look at material handling items. And ultimately, we want to virtually run off this equipment before we purchase it, build it, install it, and launch it, and ultimately find that there's an issue, right? Again, we want to catch and resolve these issues as early and as upfront as possible. Little bit more specifics on some of the kinds of tooling studies that we do. We do a lot of work with tool and socket selection. So checking that the sockets are going to clear or have the correct clearance. And we have a database of standard rundown tools and sockets from a variety of manufacturers that we can just bring into the simulation model to do this kind of analysis. So whether you're using, Apex or Kokin or Atlas Copco, whoever the manufacturer is, we have those resources. So you can see an example of this on the right here, where in the top photo, the socket is actually colliding with the assembly, the socket that was selected, and we're able to, select a different tool to resolve that issue long before it hits the floor. We're also looking at things like the torque requirements, right? Do we need to use a 3/8 or a 1/2 inch drive tool? Also want to consider ergonomic requirements, which we'll look at here in a minute. And then again, if we do find issues, we can work with manufacturing and product development to resolve those issues long before launch. Bit on ergonomics for tool and socket selection. We want to think about the operator always, right? So which kind of tool is the best fit based on the assembly's height, orientation, clearance to other components. If there's other equipment surrounding them, where do they need to stand in order to be able to perform this task? And then the ergonomic things that we're considering, right? So things like wrist deviation, line of sight, hand and finger clearance. So we can see an example here on the right where in the top photo, first of all, the operator's knuckles are actually colliding with the conveyor here. And we can see that their wrist is pretty heavily deviated, probably not a very comfortable working posture. So we can very quickly and easily in the software just select a different tool. You can see on the bottom here, a right angle tool improves the clearance, improves the operator's posture. We can also create any number of kinematic objects in the Process Simulate software, which is extremely powerful. I think people often think of kinematics in terms of just robotics, right? But we can look at any kind of mechanism in the software. So we can create a physically correct mechanism and then run off any kind of tooling prior to purchase or build. So we can see an example of a tree here on the left of the mechanism that we've created. We can establish interdependent joints, joint limits. So you can see this lift assist will not move outside of its range. And then we really want to take a system level approach to design, right? So looking at interactions between tooling, the product, the layout, the packaging, the operators. I couldn't tell you how many of these kinds of studies I've done where, sure, the lift assist works great. It will pick up the product, but no one considered, the operator's walk path from the line to the dunnage that's being packed out to. Or in this case here, we can actually see we have a collision between the lift assist and the packaging that the assembly is being moved into. When it's highlighting red there, it's colliding. So taking that system level approach to design, you often see interactions that you may not have caught otherwise when everyone's just working in their own little sandbox. I won't spend a lot of time on this because we're more focused today on really like manual processes and workstations, but we do some work with robotics in Process Simulate. So we can set up the robot in the software, set up the kinematics on the end of arm tooling, and then take a look at things like the robot's reach, its interaction with the product, interaction with the packaging, can it perform the tasks that it needs to do? Another area where we spend a lot of time with our clients is in layout development. So you don't necessarily need to begin with a 2D layout, but many of the clients we work with, they're still working at some level in AutoCAD or some other 2D drawing package to draw the facility layout. And that would have information about aisles, walkways, columns, where the marketplaces are located. And we can actually bring this 2D model into Process Simulate to sort of act as the floor, the carpet, that we then place our 3D resources on top of to develop and optimize our workstation layouts. So using this 2D in conjunction with 3D really enhances our understanding of the process. So for this kind of layout development, we would bring in 3D models of, again, anything that would be present on the plant floor, right? So tools, machinery, material handling items, platforms, ergo mats, tables, whatever may be present physically. If we don't have access to everything that we would need in a particular workstation or cell, we can very easily create primitive shapes in Process Simulate as placeholders, until we can get that information. So I think that's really powerful and helpful to, kind of sketch out designs and play around with different scenarios. Again, we always want to consider our operators, right? So clearances for ingress and egress, how can they get in and out of the station? Pinch point clearances for safety, arc flash clearances, and then taking a look at relationships with neighboring stations, right? So if we create a simulation model of the entire line, we can really see how all of these stations interact with one another. And we can see an example on the right of two different layouts for the same workstation. Doing these modifications in Process Simulate takes a matter of minutes. Basically, it's select something you'd want to move, drag it to the new desired location. We can take dimensions and really evaluate the new layout and the new process. So this allows us to experiment with potential scenarios and processes much faster than physical trials. And again, we always want to vet anything before we allow it to impact the production floor. We also use these layouts pretty extensively to help develop time studies. So having a space to visualize and experiment with these processes. We work pretty extensively in ModApps, which is a predetermined time standard. So you can use the simulation to help develop those codes for your ModApps or MTM time studies to ensure that your process is going to be within cycle time. We can then optimize the layout to reduce the cycle time and really change it to meet whatever the requirements are, right? So whether that's space, cycle time, ergonomics, material handling, again, much faster than physical trials. And then obviously we want to be able to feed this information and all the great work that we do in Process Simulate back into other tools that our clients may be using, which is very easy to do. So changes in the 3D environment can then be flattened to update, let's say, a master 2D layout in AutoCAD. So you can see an example of that on the bottom here, where we've got the 3D resources and overhead view on the left, and the flattening that Process Simulate generated that can then just be directly imported into AutoCAD on the right. And of course, we can also export out 3D models of anything in the scene. So that could be a single tool, could be the product in some position. We can even do stations or even full lines if necessary. And with that, I will pass it over to Mitch to talk to us a little more about ergonomics and human-centered design and Process Simulate.
Awesome. Thank you very much, John. So absolutely, I'm going to start to talk about how we can take all of the great work that John does in the upfront stage, really looking at setting up a scenario and a simulation, and how we can really validate that the design is going to be impactful and acceptable for the operators on the line. So we can see a quick video here of how we're quickly able to relocate and adjust the pitch of different objects and how that impacts the positioning and the posture of the human. So with that, we're able to quantify a good amount of human limitations. The big ones that we typically are going to be assessing are going to be for reach, hand access, finger clearance, ensuring that we're able to get into where we need to get into for a manufacturing process, as well as evaluating line of sight. And I think one of the biggest ones that we can really provide upfront is going to be strength capabilities as well. If we have an estimate or an understanding of what a potential force is to install a component, the weight of an object, and we do have a rough idea of what the station is going to look like, we're able to update the posture of a human model to really identify what that posture looks like. And using the Process Simulate software, there are a multitude of ergonomic assessment tools that are built in where we could assess for strength capabilities as well. The other nice thing about working within this environment is we're not limited to a static assessment. So what I mean by that is kind of what you're seeing right now, where we just have a human model. We're kind of adjusting that around. We're looking at stuff that's all stationary. That's all fine and great, but we're also able to look at a simulation or a dynamic environment here where we have the mannequin moving through a series of motions and starting to look at the effects of some of the cumulative tasks there. One of them being back compression over the course of a shift. We could really start to investigate the impact of workstation design and make tweaks and adjustments to that to really update and optimize it for the worker in the workstation. And then, of course, all of that information just goes right back to the start and can really help prevent costly changes once implemented at launch. So really trying to get upfront and early in identifying potential issues. So just a brief overview here for those that aren't familiar, what exactly is a digital human model? So we have our Jill mannequin here. She's waving at us, saying hi. So we have a digital human model here, which is going to be a computer generated representation of a human being. Traditionally, these have been a little bit more blocky, almost like almost something out of a child's video game. But as we've kind of progressed and technology is rapidly increasing, we're really able to get a lot more of a smooth skin mannequin here. The skin deformation is actually going to follow a lot closer to what the actual human would look like in there. As well, we're really able to customize the anthropometry or body size, height, weight, gender of each of these mannequins to really either represent an industry standard or represent your working population. So depending on your approach to ergonomics, both of these are going to be within the realm of what we're capable of doing. So these models are really used to simulate tasks and really identify potential issues that we're seeing, such as like reaching for an object that may be there. Perhaps it's a rundown tool that's hanging overhead. Really evaluating what height that needs to be set at early on, or if an operator is going to be able to reach around, let's say, to the backside of some product that's on the line and see if they're going to be able to possibly install a bolt there. That can all be assessed with our digital human model here. And then, as I mentioned, we have some real rapidly advancing technology here. So John, do you mind just going back? Thank you. And we can really leverage this as well as like virtual reality to start to immerse ourselves in the scene. And as an ergonomist or as an engineer, get a feel for what we're really designing, whether that be posturally or just have a better understanding of what that actually looks like. We're actually able to utilize some live hands and either motion capture as well to record our motion. So we could translate that data directly from the real world being immersed in virtual reality, combine that with some form of motion capture, whether it's going to be basic level at the hands or a full body tracking, and really convert that back into the digital space here to really prevent the number of physical prototypes that we need to go through and number of different iterations that are actually created in the real world. Awesome. So just going to give a high level overview of a bunch of the different assessments that we can go through here. I mentioned reach assessments. They're typically done using an industry standard mannequin. So typically we're going to look at whether a shorter female can reach to an item on the line and just really identify what's within their grasp zone. We could also look at different ways that we can implement solutions. So the picture on the left here, we're showing a mannequin reaching down into this bin. However, based on their height and stature, the torso is actually colliding with the edge of the bin, which significantly limits their reach down into the bin. However, we're able to investigate what about the potential use of a platform or an alternative solution here, maybe a tilt table for this dunnage to get right in there. I know as an ergonomist, I'm not the biggest fan of this posture here, but we're able to even just visualize what that would look like if someone were to say, hey, what if we put a platform in here and we no longer have that torso clearance? Well, now we can see that there's going to be a lot of strain on that low back as well. And we could really quantify what that compression limit would, or what that compression value of the back would be. The other big one that we really go through is hand and finger clearance. So as John showed with some of his simulations there is a robust collision detection system built into Process Simulate here that doesn't just apply to product or CAD to CAD objects here. We could also utilize this to identify collisions or near misses for the human as well. So we were able to capture just the hand geometry of this human, look at the design of our product here, and look at if there was enough finger clearance for that operator to hand start this bolt prior to using a rundown tool. So we were able to posture that hand, really dial that in so we could see that there is very marginally acceptable hand clearance. And if there was opportunities for improvement there, we would likely push for those. But it paints a really good picture as opposed to just here's a hand, here's a bolt, and I have to take screenshots from several different sides. We're quickly able to see using some color grading whether or not we're in a near miss state or in a state of collision. As well, we're able to do line of sight analyses here, where we're able to either identify what the operator would be viewing at based on their position and posture. So we could see here, we have the vision window in the center of the screen here, and that's going to be what the mannequin is going to be directly looking at. We're going to have different opportunities or different options for what we select. We could look at even just left eye only, right eye only as well, and kind of get that stereoscopic view. Or we could just visualize using vision cones here. So that's what's projected on the right-hand side there. We have the field of view of the mannequin set to look at this monitor, and we could see that a majority of it is covered within their primary field of view. We're also heavily utilizing the software for strength assessments. So we look at a bunch of different tools here within Process Simulate. We do have the ability to use Force Solver, which is a multiple axis way to identify the max acceptable force given a posture of a digital human model. This will take into account muscle effect, the joint angle, and the joint torque. And we're able to look at this based on the percent capable. So typically we're looking at industry standards when we assess for strength. And we're able to even customize this if, let's say, you're looking for a particular population of strength, if yours doesn't match up exactly with that. So we're able to customize for who we're designing these jobs for as we go through and assess. There's also a whole bunch of other features that include investigating the max acceptable force if we're bracing, if we're utilizing any external support, or if we're going to be standing on one foot, as that could impact how we're able to model or what forces are going to be acceptable from there. As well, we look at back compression, anterior posterior shear, and lateral shear, given the weight of an object here. So we can see we have our mannequin postured, lifting out this garage door opener or placing it to the dunnage here. and we could see maybe not, but roughly about 11.6 kilograms would be the max acceptable weight with the given parameters here. So as I mentioned, the Force Solver is one of the key ergonomic assessment tools that's built into Process Simulate here, but there is a large variety of other assessment tools as well. We go through different screening tools such as OWAS and RULA, EAWS, but we also have more robust tools such as NIOSH available, static strength evaluations, low back compression, the arm force field. And then once we get into creating simulations, it opens us up to even more opportunities for assessment, including timing walk analysis, strain index analysis, and even some form of energy expenditure as well, if you're looking at a metabolic study. So here we have a video of what it would look like to create a simple task simulation here. So we have the operator lifting the garage door opener off of the conveyor and placing it into our dunnage here. We're able to kind of see, wish the video was a little bit more clear, but what we could see is we have our static strength numbers up above the mannequin's head that will update in real time as the mannequin moves and changes their posture. So we're able to identify at different points in time what the actual static strength is. As well, we're able to use this in conjunction with our collision viewers, and we could see here that the current proposed layout of the product within the dunnage is causing some collision with the left hand of the mannequin. One of the newer features that's been kind of progressing rapidly within the field of ergonomics is the use of virtual reality. So it's gone from just being able to be a simple viewer tool where you're able to immerse yourself, hop around and view what the product looks like and get an understanding of different positions, to where we're now able to utilize virtual reality headsets as well as some accompanying trackers to actually do full body motion capture here. So we'll go through this video here where it's going to showcase some of the features, including object gravity, where we're able to simulate an object being dropped and it will actually fall down and follow the gravitational properties of Earth, which is really cool. But we're also able to leave an object in space and regrasp it as well. And you'll notice that the hand posture as we go through there will update with the grip itself. There are also opportunities to utilize virtual reality in this method as training tools. We could see that as a mannequin was about to place down that brake caliper, we were able to see a highlighted area of where that particular item was going to go. Similar with that bolt, we had a highlight of green going there. So for any new operators coming into the job, potentially going through a virtual environment, much less risk to the product and actually for their safety as well, to kind of get immersed in what the scene would look like and what the job would entail going through. We're able to hand off objects from one hand to another here and simulate a rundown. So just holding it in position and what that posture would look like. And all of this is actually recorded here so that when we do leave the virtual reality setup, you can have this playback on the 2D screen here and actually go through and do any ergonomic analysis that you may require. So we'll zoom in, we'll see the posture that the operator in VR was going through while they were placing the caliper to its final position. And we would actually be able to break this up and view or pause this at any point in time and create an ergonomic analysis based on whatever we were looking for from there. Awesome. And so,
Thanks,
yeah, no problem. I'll leave it to you, John.
Yeah, sure. So hopefully you learned a bit about Process Simulate and some of the great work that we're doing for our clients in the tool. I guess, Brian, were there any questions in the chat?
You know, there are some questions here. Some of them were asked kind of early on, so I think we covered them, but let's just make sure we got them covered. One of the questions is, does this tool predict the time for a person to perform a task?
Yeah, so we have not used it directly to do that. But we've had a lot of success using predetermined time standards. So in particular, ModApps, I'm ModApps certified. We have many other team members that are ModApps certified. and using that 3D environment, right, your simulation to determine the inputs for that time standard is really powerful and really helpful. So directly, no, but you would get a much better sense of what your cycle time is going to be, what the required tasks are from going through, this kind of a simulation exercise, than you would just trying to guess on like pen and paper, right? Or trying to predict what the process is going to look like without some kind of simulation or visualization tool. There have been many times, in particular in our work with the automotive OEMs, where we have some preliminary time study, and then we build up the simulation model and redo our ModApps codes. And the initial time study was wildly wrong, which often drives changes to the process, rebalancing, or implementation of other solutions to try to reduce the cycle time. So it's very useful for developing cycle times.
Yeah, and there's an associated question from Sean, and I think we've talked about this, but it says, does it support the ModApps time standards?
So again, yeah, not directly, but it is just we've done a lot of work and had a lot of success using the tool to develop the ModApps time study, right? Determining what your reaches are, getting a good look at your product and understanding, is it a simple or complex alignment? And then stepping through the simulation as you develop the code, and then stepping through the simulation again to validate the code, is very, very powerful.
Okay, and then here's one. I think this might be for Mitch here. It's referencing slide number 27. It says, of this list of ergonomic assessments, which ones are the ones that are most commonly used?
Yeah, absolutely. So the big advantage to utilizing Process Simulate as opposed to some other digital human modeling tools out there, or even some pen and paper methods, is the use of the force solver. The force solver is definitely unique to Process Simulate, as you're able to actually change the force vector and the direction of force that the mannequin would be applying. So you're able to really posture the mannequin, adjust that force vector, and really get an output almost immediately, as opposed to if we were looking, let's say, at a one-handed insertion task of a cam position sensor. Sorry for going automotive on this example, but that's one I know that we've looked at quite a bit. We're able to really kind of identify even some off-axis pushes too. So where it's not going to be directly down or directly forward, it's going to be somewhere in between there. The force solver really allows us to look at what those outputs would be, and kind of compare them to some other tools out there as well. But typically the force solver is the go-to.
Okay. How about, does Siemens or Sandalwood offer training for Process Simulate?
Yeah, absolutely. So, on the Sandalwood side, we can offer, a variety of services, whether that's training or coaching. We do a lot of consulting projects in Process Simulate. And then also Siemens has some direct training courses that they offer. We often facilitate those or deliver them for the client, but there are many different courses with different curriculum depending on what the needs of the particular client are. Again, Process Simulate is a very broad tool. Today, we've just tried to highlight at a high level some of the things that we see our clients getting the most value from. But I think, Brian, we could probably share the training site as well. But yeah, there's a variety of courses. So you could reach out to any one of us, and I'm sure we could help meet your needs.
Exactly, yes. And we have our contact information on that last slide there.
Yes.
Here's a related question from Jason. How long does it take to become proficient with Process Simulate?
Yeah, so I mean, I would say it depends on the level of simulation you want to do, or what kind of areas you're really interested in. But I would say to create something like we're seeing here, I would think you could learn in probably a week to create some really in-depth simulations. And then if you wanted to add other functionality on top of there, right, like working with robotics or working with the digital human model, could take a little bit longer, but it is fairly easy to use. But again, how long it would take to learn would really depend on the kind of simulation model you wanted to create. But it's a fairly user-friendly tool. We do training in some other software packages as well. And I always enjoy teaching this one because it's fairly straightforward.
Okay, so here we have a very specific question. What are the advantages of using Process Simulate over version 9 of Jack in terms of ergonomics and human posturing?
I can take that one, Brian.
Okay.
So outside, I'm going to start off with outside of ergonomics and human posturing. Unfortunately, Jack has been sunsetted. So actually a lot of the same functionality from Jack has been brought into Process Simulate. So you're going to continue to get updates to the software itself. So I think if you get a bad or a computer update, there is a potential for Jack 9.0 to stop running. So with regards to actually utilizing human posturing and the ergonomic side of it, there are additional tools as well as tools for creating assessments, not only through the means of simulation with the task simulation builder that was available in Jack, but also through what John is showing here as an operation simulation. We're also able to kind of simulate a human in that regard. So there are other opportunities for assessment tools, let's say metabolic and walking studies that could be completed with the operations. And you could have that tied directly into your part flow simulation here, where you would have a mannequin either go through the series of operations, turn on at a specific station. As well, one thing I find is navigating the scene. As an experienced Jack user for 4 years and made the transition pretty quickly into Process Simulate. I was using both for a while. I've really found that navigating around and doing the simple tasks like renaming item or individuals in the hierarchy or object tree have become a lot more simplified to keep a large study or even just a small study organized. So I would say that those are just a couple of the advantages of using Process Simulate as opposed to Jack.
I would also just add to that, Mitch, that we've been doing a ton of training events recently, helping ergonomists make the switch from Jack to Process Sim. So that's something we've been doing a lot of and we're very experienced in. And then just in terms of, my perspective as kind of coming from the engineering, more simulation side, once you have this model and you're going through the development of the process, it's really nice to be able to have engineers and ergonomists working together in the same space, right? So for this kind of a study, I can do some basic posturing with the digital human model, but I am no ergonomist, right? So I can do my process development work, tooling studies, layout development, all of the different things that I'm looking at in terms of the process and the tooling. And then Mitch can come into the same environment and do in-depth ergonomic analysis very easily because all of the elements of the manufacturing system are already present. So it's a very easy transition and a great workflow for getting different teams into a common space.
Okay. So John and Mitch, here's a question from Thomas here. It says, what 3D CAD drives Process Simulate? AutoCAD, SolidWorks, etc.
Yeah, so Process Simulate is compatible really only with JT models because they're very lightweight. But that being said, so in our work with some of the larger automotive OEMs, the suppliers of the equipment are modeling in whatever they're modeling in. And we're able to, get that native CAD and convert it to JT, or often we have them convert it for us. And we've also done a lot of work helping folks determine what their CAD standards should be, right? So what should these drawings look like? Where is the origin? Are there requirements for the structure of the model? So Process Simulate is only compatible with JT, but we've had a lot of success converting from, any other format to JT to be able to bring it into the simulation.
Right. Yeah. So, and I think that applies to pretty much any CAD system that
Yes.
we can pull that data in.
Yes.
Let's see. What else do we have here? Who typically uses the Process Simulate software?
Yeah, so I mean, I think two things there, right? So who directly uses it is usually someone like myself, who's some kind of simulation or virtual assembly engineer, also ergonomists. But again, it's not really all that difficult to use. So in theory, you know, anyone could learn to use this tool. But I think what's important to note is that you don't have to be a direct user to really get a lot of value from this kind of exercise, this kind of simulation model. So in a lot of our consulting work, you know, we're bringing together all of these folks who may never really interact a whole lot, right? So by having this common model, we can then bring in the process engineers, the manufacturing engineers, the industrial engineers, the ergonomics, the ergonomists, the packaging engineers, the layout engineers, and get everyone into this common space to discuss, make changes, iterate, resolve issues. So it's really benefits any stakeholder for the manufacturing process in the organization using this kind of approach.
Okay, and I think we have one more here, and let's see if I can interpret this correctly. It says, what is the number one benefit reason that people use Process Simulate?
I mean, ultimately, a cost saving, right? Doing all of this work up front is, you know, it's time consuming, but we've realized some very significant cost savings and issue resolution long before anything is built or installed. I think that's, you know, the biggest thing is that doing this work up front really does add a lot of value. It's sort of interesting too, because sometimes it's difficult for us to quantify those savings simply because you don't realize a cost from an issue that you resolved 6 months before equipment was going to hit the floor, right? So there's a lot of value in doing this kind of approach, and we've realized a significant reduction in issues on, you know, programs, assembly programs where we've utilized this kind of a tool, and assembly programs where we haven't.
Okay, well, I think we've gone through all the questions that are in the Q&A in the chat here.
Awesome. Well, thank you all very much for joining. I hope you learned a little bit today. We've got our contact information here. You will receive a recording of this session, and please don't hesitate to reach out if you have any questions or you'd like to have a further discussion about what your specific needs are. All right. Thank you, everyone. Have a great day.